So the question is, what's an API? Well, one thing we can do is look up its definition. Here's one: a set of functions and procedures allowing the creation of applications that access the features or data of an operating system, application, or service. It's really clear, right? Well, one of the problems is that API basically means anything that a piece of software uses to talk to another piece of software, whether that's a thing on your local computer using some library to do a cool image processing task, or your IoT sensor sending data across the globe to a cloud backend somewhere. They're all APIs, but they work on very different levels. So, for the context of digital ag data pipelines, let's just look into some examples of kind of a system level and see what we mean by APIs there. So, to sort of set the stage, let's think of a sensor that's out in the field, maybe, and it has some data it needs to send to a cloud. So, it has a connection to a cloud, and the manufacturer of that product, say, maybe makes a web app, and that web app uses a connection to the same cloud to access either the data or some processed results from that data to give you meaningful insights. And maybe that web app also talks to other backends, for example, Google Drive to get some data about you, or maybe IFTTT, which is a platform that allows you to do automation based on a bunch of data sources. Or maybe those backends need to talk to each other directly. IFTTT is a great example. It maybe needs to go into your case or John Deere Cloud uh, to pull your data so that it can react to it. Or maybe you have other sensors out in the field and they need to communicate with a gateway or a base station before it can get the data up to the cloud. And so there's a connection there too. All these connections, they serve very different purposes, but they're all APIs. And because there's so many different types of APIs, it's helpful to group them into categories. Uh, I'm going to show you three kind of rough, broad categories. You could debate the exact definitions of these categories, and if that there are only three. And I think you could also debate that a lot of APIs might fit into more than one of these groups, but it helps to kind of frame the argument and think about when are APIs used and for what purposes. So the first one is a private or an internal API. These are like the APIs that are used to kind of piece together a product. So the sensor to the cloud and the cloud back to an app. They're typically customer oriented in the sense that requests for data are responded with data just from one customer. So you log into Facebook and your Facebook app uses a Facebook private API to pull your data so it can show you. It's only your data, it's not everybody else's data. These are typically APIs that are for your company or internal to you. You don't really expect other people to use them. Then there's partner or business to business type connectivity or APIs. These are usually when two businesses have a social relationship or a business agreement to do something, and one company needs all of a certain type of data for all of their customers, and so they get it in one giant request rather than in one request for each individual customer. These are usually kind of prearranged things, and are kind of maybe one off or controlled very tightly with prearranged secrets. There's not really like usernames and passwords that go along with them. IFTTT would be a great example. Maybe IFTTT reaches in and gets all of John Deere's, a certain piece of data for all of John Deere's customers all in one request so that it can do automation around that piece of data for everyone at once. And then lastly, there's sort of a public or open API. This could be something like the Regional Climate Center's ACIS weather service, which is a big database of daily weather data from stations all over the country. It's completely free. It's a public service. There's no username or password. There's no authentication. Or it could be an API that a company has created so that they can enable integrations with other parties. And there might be some sort of restrictions or even costs associated with that, but the documentation is public and the API is sort of easy for people to read and use. It's intended for other people to consume it. Okay, so we've established that in the digital world, things are connected, particularly in the digital ag data pipeline world, things need to be connected. And they're connected by this API, but what exactly is an API? We haven't quite gotten there yet. And it's a good question, but to really get there, we need to talk about how we're going to communicate, because what an API is really dependent upon that communication channel. And those are what we call protocols. It's the means in which we communicate, but not necessarily the language. You can think of a protocol as like the telephone. You can pick up the telephone and talk to somebody across the world. But if you haven't decided that you're going to speak English, for example, you won't really be able to communicate, even though you have an open connection. So there are a lot of protocols that are used in modern sort of web APIs. One of them, for example, is MQTT, or Message Queue Telemetry Transport. This is like a publish describe. It's a kind of a full architecture for IoT data. You can think of this as like a mailing list. You subscribe to a mailing list that you're interested in, and then someone who has information that's relevant to that topic can post an email to it, and then everyone who's subscribed gets that email. That's really what MQTT does, but except for data coming off of sensors. There's WebSockets, which is just like the telephone. It gives you this two-way communication link, but doesn't really define how you use it. There's HTTP, which is what your browser uses to browse the web. So when you go to google.com, your web browser uses HTTP to talk to a Google server and pull down Google's website or your search results. You can think of HTTP as like a mail service, like USPS or UPS or FedEx. You sort of put your order form, for example, into an envelope. You mail it to the company that you're interested in. USPS brings it to the company. The company reads the order form, finds the product you want, puts it in a box, and gives it back to USPS to deliver to you. And so USPS is kind of like HTTP. It just does this round trip sort of request response type of process. And then gRPC is like built by Google. It's for doing remote procedure calls. This is more popular on the cloud side of things, but it is starting to get into the front end of IoT. This is a lot like your boss giving you a call and saying, "Hey, I need you to do this task for me." Then you doing that task and then just giving the answer back to your boss. So that allows a client to ask a server to run some piece of code on its behalf and then just give it the answer. So there are a lot of other options out there as well. But by far the most popular one in today's world is HTTP. And so we're going to go ahead and just look at only that for the rest of the talk. So what is an HTTP-based API? Well, to know that, you kind of have to understand, what does HTTP do? We've already talked about it being kind of a mailman-y thing, but let's get a little bit more specific. So you can make HTTP requests, which go to a place and a path. And this is an example of a path. So the path is pictures/dog.jpg, and the place is example.org, or the address, if you will. Going back to the mailman example, we can put our request in a box. We can address it to example.org. And then when the box gets delivered to example.org, it opens it up and sees pictures/dog.jpg. It understands what you mean by that. It's a path to a specific resource. In this case, it's a picture of a dog. So it puts the picture of a dog in a box, sends the box back to you. Maybe it got beat up a little bit in transmission, but either way, once it gets to you, you open the box and inside is the picture you're looking for. So you made a request for a specific resource and then you got it back. That's really all HTTP is about, except that it does it using a text protocol instead of English or paper in a mail. Okay, so we're going to use HTTP. Now, what's an API? And again, it's a good question, and it's a good question because really you need to tell me. Because really what an API is just some agreed upon means of understanding the data format and the meaning behind it. So I can send you data that you know how to interpret, and you know what to do with it when I send it to you. That's what an API is. Or I'll say that's my definition of an API. It's probably lacking some technical details, but essentially, at least at a data pipeline point of view, that's what we're after. The problem here is that you still have to have that pre-agreement. Everyone needs to know, well, how will the format look, or how will the data look, and what am I supposed to do with it when you send it to me? So there have been some attempts to standardize around that, because with those questions not well defined, interoperability or the ability to work together is hard. One of them is OData, It's an OASIS standard that then was eventually approved in ISO and IEC. It's basically a big set of best practices around building what they call RESTful APIs. And RESTful APIs are really the dominant type of HTTP API out there right now. And really everything we talk about would in this talk kind of falls under the name RESTful API. And the way it works is it has common data models. So everyone sort of formats the data in exactly the same way. And that allows interoperability, because if you just say, oh, I speak OData, then you know how to read the data. And resources can point to other resources. So just like the web, where you can click links to sort of find data about data, you can do the same thing through an OData API. There's still a problem on the other end of you have the data and you know how to interpret it, but you don't know what it means unless you have that pre-arranged negotiation anyways. And so it solves a lot of the problem, but it doesn't solve the social problem of what am I supposed to do with the data once I get it, and what does that data mean actually in the real world, not just from a bytes perspective. Another example is the Open Ag Data Alliance. It's also known as Trellis in the food safety world. It's essentially the same API. This was created by the Oats Center and by my colleagues. And it's an API that allows the data to define the API instead of the API to define the data like OData does. And what we mean by that is, as you put up resources, we read the resources and make new paths based on all the different sort of sub data that's part of that data blob that you put up. And then all those are linked together, creating this big graph. And you're then able to kind of query or walk down this big graph by appending together the various paths. It's a lot simpler than it sounds, and it's actually quite a general, powerful idea. I encourage you to look at our reference implementation. You can find that here, or if you'd rather just some specs about the API, you can look at our API documentation here. And finally, the last thing OADA does is it defines not just common semantics around how you put and edit and query data, but also around authentication and authorization. And that allows for real practical interoperability, in the sense that if two places are OADA conformant and I have an OADA identity, I'm already sort of a user of both platforms, even though I may never have used them before, because they all share a common authentication and authorization backend. Okay, so we've defined what an API is now, and we've even defined some examples of standardizations around that, but we haven't really talked about formats. So we now kind of know how to communicate, but what language are we going to use? Are we going to use English or Spanish? Or in the data world, is that going to be just like raw bytes, raw binary form, or is it going to be JSON or YAML or XML or all these different, or shape files, or all these different types of file formats that are out there? Right now, the popular choice, and I would say pretty much exclusive choice for newish APIs, is JSON, or the JavaScript object notation. And the real reason that JSON is popular is because web browsers know how to process it natively. So it just became a really convenient format. It's not that hard to read. Hopefully you can see what this means. This is basically a resource for a temperature sensor that has this location in lat and lon. It has units of degrees Fahrenheit, and these are 3 different data points that it returned. So now you know all about APIs. Let's look at some of the gory details. So going back to our mailman example, we need to know what to put in the box. So HTTP is a very simple protocol. It's completely text-based. And so the first line of an HTTP request is the request type. In this case, it's a GET. We're saying, please give me the data that's at the path/test. But it could also be a put or a post or delete. Put's like an edit. Post is like a create, and delete deletes. In the details, there's a little bit more in the details, but that's essentially good enough. And then all requests have request headers. That's these lines here, and it can be more. And it's really about metadata about the request. So in this case, it's like the address, example.org, that what gets put on the outside of the box. User agent is essentially the carrier. So instead of USPS or UPS, it's the program that created the request, like curl is a command line tool. And accepts is sort of the form factor, or the format of the data that you're willing to take. So the server may know how to respond with that resource in different formats and you're sort of pre-negotiating. Here we're saying all formats are fine. And then usually there's a request body, but because that doesn't make a lot of sense to have a body for a get, you're just saying, please give me that thing, it's empty. But a put or a post obviously have a body. It's the data that you want it to be or create. So all this gets packaged up into a box and then sent to the server. The server processes it and responds, and its response also comes back in the box and looks something like this. It has a response code. In this case, it's 200 OK. That means all things are good. There's lots and lots of response codes. For example, another one is 404 not found. That means you asked for a resource I don't know about, and so on. They also have headers that are metadata, and then they have the response body. In this case, it's HTML. It's designed for a web browser, and a web browser would render it into an image that looks like this. In a JSON or in an API, it would usually be a JSON document of data. So let's just give a real quick example. Say we wanted to get a sensor data from a temperature, and my data is hosted at mydataapi.org. And then there's a path /sensors, which contains all of the sensors resources, /temp, which contains all of the temperature sensor resources, and then /2, which is the number 2 sensors resource. So if I go ahead and get that, then I'll come back with a JSON object that just looks a lot like what we saw before. It's all the data about that sensor. If you notice, when we sent this request in, we added an authorization header, and it's this thing called a barrier token. We don't need to get into the details, but this token right here is essentially a short-term password for me. I probably used something like OAuth 2.0 to trade my username and password with the server to get that token. The app would have done this in the background. And then the app starts using this token instead of my password. That way, if it gets compromised, it's a little bit easier to control the leakage, because that token's not really useful to anything other than this particular request. You'll see that in Zach's demo here in a second, where you need to use this to access his private WHIN API. And then lastly, we can try to add new data to the sensor. So now we're going to do a post because we'd like to create new data, and we're going to post it to the path sensors temp2/data because we're trying to tell the server this is a new data point. And we can go ahead and just send it a JSON object with the temperature, the new temperature. And then it returns an OK 200 response, which means all things are good. And for convenience, it responded with the new resource just so we know what it looks like. And you can see it added that new data point.
Here at WHIN, we've developed an API that enables real-time access to weather data from our local farm fields in the WHIN Weather Network. Access to the WHIN Weather Network API is available for free for educational use, so you can replicate my actions in this video and follow along if desired. My goal today is to peel back a little bit of the mystery surrounding APIs by demonstrating how to access an API that requires an authenticated account. I will be using the freely available Postman tool to connect to our weather API to view the current weather conditions. The WHIN Weather Network is a relatively dense deployment of over 150 Davis weather stations. Each station is equipped with standard weather sensors like temperature, humidity, wind, and rainfall. Additionally, each station has 4 separate soil temperature and moisture probes to track conditions vital to crop health beneath the surface. Here, you can see our map at whin.org/weather. Each triangle represents one of our weather stations. Clicking on one of the triangles brings up this pop-up to show you a visualization of the different weather sensors. The 4 soil moisture probes are installed at 2 inches, 5 inches, 10 inches, and 15 inches below the surface. The WHIN website uses the Weather API to build this graphical representation of the data. Before we can look under the hood and see how this API connection is made, we first have to create an account at the WHIN data portal. To do that, navigate to data.whin.org and scroll down to the bottom of the page where you see the Weather Data API. Click on More Details, and you can read about the API. Click on Create Account to create your account. Indicate whether you are a student, educator, or a researcher. We do not make this data available to commercial entities. The account creation process is straightforward. Simply indicate how you want to use the data,
put in a valid email address ending with your educational institution account. A confirmation email will be sent to your email address. Simply click on the link to activate your account, and you will be good to go. You can see that we've received an API authorization token, which we're going to use in the next step when we connect to the API. But before we do that, let's take another look at the documentation. We now have access to the sample data. This sample data is made available under a Creative Commons license for non-commercial use. Let's open that up and take a look at how the data is formatted.
You'll see that the sample weather data is just numbers and text. There's no styling information or any hint of how it should be displayed. That's up to the application that downloads and accesses the API. In this case, we're just looking at it in a spreadsheet. We can see that this is all data from station number 8. That identifier is something we can look up in a different table, but we're also provided with the name of the station. This is one of the public WHIN weather stations. And these other columns here will show us where it's located in space. We have the GPS coordinate, latitude, longitude, and what time each observation was taken. You'll note that this one changes for every row in increments of 15 minutes. These readings were taken on May 1st of 2020. And if we scroll all the way to the bottom of the sample data, we'll see that they end on June 1st. So this is 1 month's worth of data every 15 minutes at this single station. Let's take a look at some of the other columns. We have a few temperature columns giving you the average high and low temperature for that 15-minute period. The humidity, and that's a percentage. Solar radiation, measuring how much sunlight is hitting the sensor. You'll see that during nighttime that's 0 and it grows during the day and then wanes again as it gets closer to nighttime. And we have rain, wind, and pressure, all pretty standard weather observations. Additionally, we have these soil temperature and soil moisture readings. These last 4, the soil moisture readings, are a little difficult to understand. You'll see that they do not change very frequently, and the numbers are slightly inverted to what you would normally expect. So low numbers mean the soil is moist, or more accurately, it is easy for a plant to move moisture through the soil or draw moisture up through the roots. So during the month of May, the soil looked like it was all very low numbers. The highest these numbers get is 200, which means it's completely dried out. All right, so that is the data. Here I have the documentation for the WHIN Weather Data API. It gives a brief overview of how you create an account like we just did, how to authenticate against the API, and common error codes. We'll look at the authentication portion first. It says all API users must create an account and agree to the terms at data.whin.org. After confirming, we just need to send our API token in an HTTP header named authorization. It looks like this: authorization : bearer, and then your token. Don't worry if that doesn't make any sense to you. The tool we'll be using to connect to the API, Postman, already knows how to send a bearer token for authorization purposes. What's important is to understand that some APIs require account access and require you to send some sort of a secret token that authenticates you and gives you access to the data in the API. Let's go down to look at the next part of the documentation, which is the endpoints. Endpoints being a fancy word for a URL, that tells you what kind of requests we can make to the API. The first one here is a listing of all weather stations. When looking at an endpoint documentation, it's important to check to see if there are any parameters that you can send and what the response data looks like when it comes back. So you can ignore this code section here, and let's look at this example response. So this is what the data should look like when we ask it to list each of the stations that we have access to. This is in JSON formatting. You can tell that because of the all the curly braces and quotation marks, but you can ignore that and just look at the content here where it's showing for each of these weather station pieces of data. It has 4 attributes: an ID, latitude and longitude, and a name. So each of these represents one of the weather stations. ID number 158 here is at the West Central High School in Pulaski, and gives you where it is. So we will expect the data to look like that when we make this request. Now let's use Postman to connect to the API. Postman is a free tool that's useful for debugging and experimenting with new APIs without having to learn how to code. Once you know the basic terminology that APIs use, like making requests, reading responses, and connecting to endpoints, you can configure Postman yourself to access hundreds, even thousands of APIs. Some companies even provide templates for accessing their APIs via Postman. For the WHIN Weather API, first we need to set up the access token to authenticate ourselves. There are a few ways of setting this up, but the simplest is to say new request. We'll say that this is listing our WHIN weather stations. And we're going to save this in a collection called WHIN Weather API. All right. So in the WHIN Weather API, we have a request called list WHIN weather stations. Now we haven't told it how to do this yet. There are 2 parts. We need to enter the URL for the endpoint, which we find in the documentation. It says get, that's the method that we're using, and the URL is data.whin.org/API/weather/stations. So we have get as the method. Our URL, if we try to send it now, we get an error, 403 forbidden. Access to this resource has been restricted. We receive this error because we did not set up the authentication yet. We can do this in the Authorization tab right here. Choose Bearer Token as the type of authorization. I already have my token from the API here, but go back to the account page on data.whin.org, copy the token that you are provided with, and paste it in here in order to access the API. We should be all set up right now to make this request. So I'll try send again. And this time, we receive some data from the API. It looks exactly like the sample data that we just looked at. In fact, we have all of these different weather stations. Now that we can list the stations, let's try getting some actual weather data. We'll do that by adding another request to our API here. Connection, add request. This one will be retrieve current conditions. This retrieves the current conditions from all weather stations that we have access to. We'll set up the authorization the same way with the bearer token. And we'll check the documentation. See, for this endpoint, to retrieve the current conditions. I'll paste that in here, hit send, and here we have all of the current weather conditions you can look at the timestamp and see that this is indeed real-time data from today, October 26th. The timestamp portion, you'll see a Z after it. It means the time zone that it's using is UTC time, or Greenwich Mean Time. So you may need, that's a standard that's often used with APIs and computer systems. And all of the rest of the data looks exactly like we're expecting. But you might have a question of, how can I use this data? How can I at least open this up in Excel? You'll notice again that the formatting on this isn't exactly human readable. It's meant for programs to use, although it isn't too hard to see what's going on. The JSON formatting. Let's try altering our request to ask the API to send the data in CSV format, which is editable in common spreadsheet programs. Postman makes this incredibly easy. Go to the Params tab here, and let's look at the documentation again and see there are some parameters that allow us to change the request and the response that we get back. So one is the format, which is defaults to JSON, but we can pass CSV instead. So let's try that out. I will enter a new query parameter. The key will be format, and the value is CSV. And you'll see as I type here, it just adds that query parameter to the URL. You can type that in up there if you want, or in here. Doesn't matter. And we send that along, right? It comes back in a slightly different format. You'll see all of the column names here, and all of the data for each row separated by commas. To me, this is actually harder to read, but the point of this is to open it in a spreadsheet. So if I click on send and download, it actually gives me a place to save that, and I can open up that file in a spreadsheet and look at it that way.
All right, we've tried two different endpoints. We've downloaded the list of weather stations, and we have downloaded the current conditions from all stations. Let's try the third endpoint, which when we look at the documentation, says that we can view historical weather data for a given date for a single weather station. This endpoint has two required parameters: the station ID of the station that you want to look up and what date you want to look up. So let's say we wanted to see how much rain the Cumberland Gardens weather station received last Wednesday. I can look at my list of stations and see that Cumberland Gardens is station ID 41, and last Wednesday was October 21st. So let me add this third request for the daily historical conditions. I will copy in the URL for this endpoint, set up the authorization the same way with our token, and we'll add these two required parameters: the station ID. We're going to look up station 41, and the date is October 21st. You can format it in a variety of ways. This is probably the least ambiguous: year, month, date. Let's try that request. All right, this returned it in JSON format, but let's say if we wanted to open it up in our spreadsheet, we can do it in CSV. I'll save that, open it up, and we see that we have observations from October 21st. And in the rain column, I forgot to mention this earlier, these numbers for rain are hundredths of an inch. So we do see that we've got some rain over these 15-minute periods. I could select the entire column and see that the sum is 50 hundredths, or half an inch, on October 21st. So in conclusion, perhaps you're thinking that that seemed like a lot of work for just a little bit of value, but remember that the major advantage of using an API to get data is that the requests you make can easily be automated, combined with calculations, and even with other API data streams. With just a little bit more effort, we could write a script that checked the rainfall at nearby weather stations and maybe sends an alert if there was too much or not enough rain in a given time period, or perhaps if the soil dried out beyond a given limit. Now you've seen how easily you can request data from an API to stream local Internet of Things data with the help of a few simple tools. I hope this demonstration helped you better understand how the data pipeline works in ag.